Hello everyone, my name is Safal. Welcome to another interesting session here at Code Heroku. At Code Heroku, our mission is to make world class computer science and engineering education accessible to millions of students, especially in developing countries like India. In our today's video, we will be going over some of the recent trends in deep learning and some of the major breakthroughs that AI has achieved recently. So let's start with the video. The first trend is improved natural language processing. Although natural language processing has its roots in the 1950s, but there have been significant developments since then. One of the major breakthroughs was achieved recently in May 2020 when OpenAI released GPT-3. GPT-3 is an autoregressive language model that can produce human-like text. It can write stories, it can write scripts, it can write poems, articles, and it can even write code. Like in this example, the guy gave GPT-3 instructions of what he wanted to create, and GPT-3 was able to write an entire JavaScript code for that application. Although there are many language models that have been released till date, GPT-3 is different and powerful, one of the reasons being its sheer size. It has 175 billion parameters, which makes it the largest built neural network till date. If we look at this graph, there is no comparison between GPT-3 and other language models when it comes to the number of parameters. The another reason for the success of GPT-3 is training. GPT-3 has been trained on 45 terabytes of text data. Most of the data is taken from Common Crawl, which is an organization that collects data from web and provides its datasets and archives for free. WebText2 is a website that contains text data from different web pages, and 22% of the data was taken from it. Books 1 and Books 2 are two internet based books corpora, and 88% of data was taken from each. Some of the data was also taken from English pages that were in Wikipedia. Looking at the working of GPT-3, GPT-3 just takes an input which is a sequence of words and tries to predict the next word in the sequence, and it does so using transformer neural networks. Nowadays, transformer neural networks are being extensively used in language models as they are able to process each word in the sequence parallelly, unlike RNNs and LSTMs that process each word in the sentence one by one. They are also able to find the relevant words in the sentence. For example, in this sentence, the sky is full with the output given by GPT-3 was the sky is full with the clouds. That means it was able to find the relevant word in the sentence is sky. If this word would have been changed to something else like bottle, the output would have been different. Another interesting thing about GPT-3 is that it comes pre-trained. So if we want to perform some other task with it, we have to provide it with some examples rather than providing an entire data set. For example, in this task, GPT-3 was asked to remove unwanted symbols between the letters of a word and creating words from jumbled words. Now, zero shot in this graph means it was given no examples. One shot means it was given only one example. And few shot means it was given some examples in the range of 10 to 100. So, when it was given zero examples for this task, it had an accuracy of 10% approximately. When it was given only one example, it was able to achieve an accuracy of more than 40%. And when some examples in the range of 10 to 100 were given to GPT-3, it was able to get an accuracy of more than 60%. So we can see how significantly natural language processing has improved in recent years. This was all about improved natural language processing. Now let us move to the next trend, which is the long-term goal of AI is to solve advanced real-world challenges, and games have served as a stepping stone in this path for decades. From backgammon in 1992 to chess in 1997 to Atari in 2030. But yet again, the credit of taking AI in gaming to the next level goes to OpenAI, when on April 13th, 2019, OpenAI 5 became the first AI system to defeat the world champions at an esports game. OpenAI 5 defeated Dota 2 world champion group OG. Before getting into why this is being considered a major breakthrough, let us understand how Dota 2 is played. Dota 2 is a multiplayer real-time strategy game which is played in matches between two teams of 5 players, with each team occupying and defending their own separate base in the map. Each of the 10 players independently controls a powerful character known as a hero who all have unique abilities and powers. A team wins by destroying the other team's ancient, which is a large structure located within their base. Moving ahead with why this is being considered a major breakthrough. First reason is long time horizons. Dota 2 runs at 30 frames per second for about 40 to 45 minutes, which makes the input given to the model very complex. Second is partial observability. The model only has partial observability of the area within its proximity, unlike chess, where the model can see the entire game. Third is high dimensionality. Fourth are the complex rules of the game. And fifth is that the game requires long-term strategic planning. That means if the model takes an action that is good for short term, it might happen that this action results in a bad outcome in long term. OpenAI used a machine learning technique known as reinforcement learning for training the OpenAI 5 model. What is reinforcement learning? In reinforcement learning, there is an agent which can be a machine learning model or a neural network model, and there is an environment. Now, the agent takes an action by exploring the environment and it gets a reward in return. Doing this again and again, agent learns which course of action gives the maximum reward. For example, if we are training a self-driving car and this is the situation, the most favorable outcome for the car is to move forward. Now, if this action is taken by the model, it will get the highest possible reward. Also, if the car moves left, it is going to dash into the wall, and we don't want that. So, the car is going to get a negative reward if it takes an action of moving left. Moving ahead with how does OpenAI 5 works. This is a simplified structure of the OpenAI 5 model as provided by OpenAI. 5 players are controlled by 5 different LSTM neural networks which are single layered and have 4096 units in the layer. OpenAI 5 receives all the information that a human receives in the form of a multi-dimensional array. This multi-dimensional observation is then processed into a single vector. Now, because of the proximity of the players, observation of each neural network is almost the same. So, to tell the neural network which hero it controls, an extra unit embedding is provided along with this observation. These inputs are then passed to the LSTM neural network and then it outputs a discrete action to the game engine encoding a desired movement. OpenAI 5 uses policy-based reinforcement learning. A policy is defined as a function that maps the history of observation to a probability distribution function over actions. The OpenAI 5 was made to play millions of games against different versions of itself to be able to create a policy that maximizes the rewards. So, this was all about how AI models are becoming more skilled than humans in playing real time strategy games. Now, let us move to the next trend, which are deepfakes. Recently, deepfakes are making headlines. In deepfakes, likeness of one person is replaced with another person in a recorded video. The recent advancements in this trend has blurred the lines of distinction between a real video and a deepfake even more. For example, look at this video.
I'm gonna show you some magic. It's the real thing. I mean, it's all the real thing.
If you have seen this video, you already know that this is not a real video of Tom Cruise. Rather, this was a deep fake, and it looks so real that unless explicitly told, it is difficult to get an idea that this is a deep fake. Now, the state of the art model for creating deep fakes is the first order motion model. This model takes two inputs. One is the source image. Another is the driving video that contains the desired motion. These two things are passed as an input to the model and it creates a deepfake using these two inputs. Now let us look how this first order motion model works. First order motion model works in two parts. First is the extraction module, which extracts the motion from the driving video. Second is the generation module that generates the motion in source image. Initially, consecutive frames of videos are passed to an unsupervised key point detector to obtain sparse key points for each frame. Additionally, local affine transformations for these key points are also found. Affine transformation is a linear mapping that preserves points, straight lines, and planes, and set of parallel lines remain parallel after affine transformations. To obtain motion, key points and affine transformations are subtracted from each other. To predict the dense motion, this affine transformations and the subtraction of affine transformation and key points is provided to another network which then gets the dense motion and it additionally provides an occlusion map. Occlusion maps are used to provide information about which areas of the video should receive high or low indirect light. The second module is the generation module. Initially, the image is also passed in this unsupervised key point detector to detect the key points of the image. Then the wrapping of features and dense motion of the video is done with the image. And then it is multiplied by the occlusion map to finally make out which parts of the image require inpainting. Finally, after the completion of the task of generation module, the deepfake video is generated. So this was all about deepfakes. Let us move to the next trend, which is efficient neural networks for embedded devices. As we all saw in the first trend where we were talking about GPT-3, it has 175 billion parameters. Now, such a model cannot be processed in devices like mobiles or other devices that do not have sufficient processing power. So, the researchers are constantly trying to find a way to basically increase the efficiency of the neural networks models while not compromising with the accuracy. Some of the research that have come up are efficient det and efficient nets that were released by Google. So let us have a look at these research. Now, when we want to scale up our model for better accuracy, we can do three things. Either increase the number of layers, that is the depth of the model, or increase the number of units per layer, that is the width of the model, or we can increase the resolution of the image. The researchers in the efficient net paper came to the conclusion that we can scale up the models while maintaining the efficiency by compound scaling, that is, increasing all three dimensions in a fixed ratio. Now, the efficient net paper talked about scaling up neural networks while maintaining the efficiency. The efficient net paper was created specifically for object detection because state of the art object detectors are expensive, and given the real life use cases of object detection like self-driving cars, expensive models can be dangerous. So let us have a look at efficient det. Now, the idea behind efficient det was that most of the state of the art object detectors have three main components. First is a backbone network that extracts features from the given image. Second is a feature network that takes multiple levels of features from backbone as inputs and outputs the list of fused features that represent salient characteristics of image. Third is a class network which uses the fused features to predict class and location of each object, making each of the network efficient while not sacrificing the accuracy was the main goal of the team. So let us look at the changes made in efficient det. Initially, ResNet or ResNet-X or AmoebaNet were used as backbone. The researchers implemented EfficientNet as backbone of this object detector. So this increased the accuracy by 3% and reduced the computations by 20%. Most object detectors use top-down feature pyramid networks. They propose bi-FPN, that is bidirectional feature pyramid networks that enables flow in both direction, that is in the top to bottom and bottom up direction. Additionally, they added weights with input features so that the network is able to learn the importance of each feature and ignore the features that does not have much importance. Finally, the regular convolutions operations were replaced by depth-wise separable convolutions. Doing all this, the final accuracy was increased by 4% and the computations reduced by 50%. Now, under resource constraints, efficient net idea can be used for compound scaling of this model. So, this was all about how research are going on to find a way to create efficient neural networks for embedded devices while not compromising with the accuracy. So, let us have a quick recap of what all we have learned through this session. We started with how natural language processing has improved significantly in recent times, especially after the release of GPT-3 by OpenAI. Then we saw how AI systems are becoming more skilled than humans in playing real-time strategy games. Then we learned about deepfakes, and we also learned about the state of the art model, that is the first order motion model, which is being used to create deepfakes, and we also saw how that model works. And then we saw about how we need efficient neural networks for real world scenarios, and we also learned about some of the techniques that are being used for increasing the efficiency of neural networks while maintaining the accuracy. Thanks guys, I hope you found this helpful. If you would like us to create more such videos, please do let us know in the comments. We will see you next time with more such interesting videos. Till then, goodbye.